Okay, good day everyone. So ngayon naman pag-uusapan natin is magnitude comparators. Okay, so itong magnitude comparators na to, this is still part of our combinational logic circuits. So from the name itself, this logic circuit compares the magnitude of its inputs. So usually yung inputs niya is a binary number. So yung size ng logic circuit na to, of how big it is, will depend on how big is our binary digit. So will it be, are we gonna compare 1 bit lang? Or are we gonna compare 2 bits, 3 bits? So habang lumalaki yung kino-compare natin na binary digits, so lumalaki din yung magnitude nung ating number. So yung ating magnitude comparator will also be a bigger logic circuit. Now, it seems, kung titingnan natin yung circuit ng magnitude comparator, if you're reading the books or the other resources that we have, medyo parang magulo, no? Parang mahirap kung titingnan natin siya. But basically, a magnitude comparator, when we understand how to design and how to make a logic circuit, is actually parang ano siya, procedural yung pagde-design ng magnitude comparator. Medyo mahirap nga lang pagka malaki na yung binary digit na kino-compare natin, kasi pag ini-interconnect na natin yung mga terminals ng logic gates natin, medyo nakakalito na siya. But if we're going to be careful, sabi ko nga procedural kanina, di ba? Kung careful tayo in every step of designing this magnitude comparator, we are sure that we will arrive to a correct or in a correct design. Okay? So, ano ba yung magnitude comparator? Sabi natin kanina, this comparator, di ba? Compares two binary numbers. And then, what does it do? I-determine niya ngayon yung dalawang number. This will have three outputs. It will display if the numbers are equal, if one number is greater than the other, or one number is less than the other. So yun lang yung gagawin nito. I-input natin yung numbers, tapos titingnan ni comparator. Ano ba to? Yung number, yung first number ba is equal to second number? Yung first number ba is greater than the second number? Or yung first number ba is less than compared to the second number? So there are three outputs. That's why we call this a multiple output combinational logic circuit. Eto, nasabi na natin, either it's equal, less than, or greater than. Now, to give you a glimpse paano mag-design ng combinational logic circuit, we will also, by the way, we will also be discussing how to design yung ating mga logical combinational logic circuit in the next lectures. Now, we will try to design today a magnitude comparator that compares 2-bit digits. Okay, so start lang muna tayo sa 2 bits kasi if we are going to design yung 3 bits and 4 bits, medyo malaki na yung ating circuit. So the design procedure has these 6 steps. First is we have to state the problem. Second is we have to identify yung mga input variables. And ano ba yung output function natin? Okay, input variables. Ilan ba yung input? Is it like 2 input, 3 input, 4 inputs, and so on? And then output function. What are our desired outputs? So in this case, since this is a magnitude comparator, our output function here is that we're gonna get the outputs where A is equal to B, and we're gonna get the outputs where A is less than to B, and as well as the outputs where A is greater than B. after that, na-identify na natin, no? Of course, we have to assign symbols, letter symbols. So sa inputs, what variable are we gonna use? What letter symbols are we gonna use? Are we gonna use A, B, C, and so on, X, Y, Z? Sa output naman, ano yung gagamitin natin? Okay? Then, after that, we're going to prepare our truth table. Okay? So, ito naman yung lagi nating umpisa. Lalagay natin yung truth table. From this truth table, we will be applying our tabulation method. So, na-discuss natin our K-map or Carnot map. So, magki-K-mapping tayo. And then, from our K-map, we will be able to obtain our simplified Boolean expression. Now, that Boolean expression, simplified Boolean expression, because we know that that expression will give us the least number of logic gates to be used, we're going to translate that, or we're going to convert that into our logic circuit, yung logic diagram natin. When we say logic diagram, it's a schematic diagram of logic gates. Okay? So, these are the procedures, and we have to follow this step by step, because if we are going to skip one of the steps here, then we are not guaranteed that we can get a correct answer. Okay, so if you're ready, let's start designing a magnitude comparator. So sige, ito yung una. 2-bit magnitude comparator. So, we have A. I-compare natin 2 bits, di ba? So, yung A natin, this is the first number. It has 2 bits. So, we will be assigning this symbol, A sub 1 and A sub 0, with A sub 1 as the most significant bit of binary digit A, and A sub 0 as the least significant bit of binary number A. We have our second binary digit, which is B. So, dahil 2 bits din yan, we have it as B sub 1, B sub 0. So, as you can see, i-compare natin, no? The number of possible input combinations here is not just 2 raised to n. Kasi ang mangyari nito, 2 raised to 2, that would be 4. But this will be 2 raised to 2n na siya. Ayan. So, it will be 2 raised to 2 times 2, which is equal to 2 raised to 4. So, meron tayong 16 input combination. So, ito na po yun. Mula 0000 hanggang 1111. So, we are able to compare all of the possible combinations of digit A and digit B. For our outputs, we're gonna name them A is equal to B output, A is greater than B output, and A is less than B output. Okay, this is the, nasa second step, third step na tayo. I'm sorry, fourth. We have already identified the problem, magnitude comparator, and then we identify the input variables and output functions, and we also assign letter symbols. Now, we are on step 4, and we are preparing the truth table. So, dito sa unang output, hanapin ko alin yung mga less than or equal. So, mapapansin nyo dito sa una, 0000, digit A and digit B are actually equal. They're both 00. So, I will put a logic 1 dito sa output. So, kailan pa sila mag-equal? Pagka 1, 1. Ayan, equal din sila. Tama? 1, 0, 1, 0, equal din yan sila. 0, 1, 0, 1, equal din yan sila. Okay? The rest, it's not equal. 0, 0, 0, 1, ano to? A is less than B dito, di ba? So, ito yan. 0, 0, 1, 0, ano to? A is less than B pa rin. 0, 0, 1, 1, A is less than B. 0, 1, 0, 0. So, mas malaki ngayon si digit A. So, that would be A is greater than B. 0, 1, 1, 0. So, mas malaki si B ngayon. 0, 1, 1, 1. Mas malaki pa rin si B. 1, 0, 0, 0. Mas malaki si A. 1, 0, 0, 1. A is greater. 1, 0, 1, 1. So, B is greater. 1, 1, 0, 0. This will be A is greater than B. 1, 1, 0, 1. A is greater than B. And 1, 1, 1, 0 is A is greater than B. Now, we have plotted all the relationship ng bawat combination. So, pag binilang natin, 16 din ito. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, the rest would be zeros na ito. We don't need these outputs. Okay, so para kompleto yung truth table natin, lalagyan din natin siya ng zeros. Ayan. So now, we already completed our truth table. What's the next step? Our fifth step is to make or to obtain our simplified expression using the tabulation method or K-map. So let's start with A is equal to B. Ayan, itong output na to. So we're gonna use K-map. So kung min terms ang tinitingnan natin, so that would be 0, 0, 0, 0. Next is 0, 1, 0, 1. 1, 0, 1, 0. Tsaka 1, 1, 1, 1. Okay, so mapapansin nyo, diagonal siya. Wala naman tong ibang grouping na magagawa. So we can already get the expression here. So ang grouping nito is paisa-isa lang. Ayan. So if we're gonna write the equation for, the expression for this, function of A is equal to B, this will be A1 prime, A0 prime, B sub 1 prime, B0 prime. So this is the first one, and then the next would be A1 prime, A0, B1 prime, B0. Okay, and then next is itong pangatlo, A1, A0, B1, B0. And then the last one would be A1, A0 prime, B1, B0 prime. Okay, so this is our simplified expression. But in the previous discussion, we know that we can still, ito kasi no, yung K-map kasi alam natin that this will only employ the three basic logic gates: NOT gate, the OR gate, and the AND gate. In the previous discussion, we have discussed that we can also use our XOR and XNOR gates. Diba? So let's try to further let's try to further reduce this. If we are going to factor out A1 prime and B1 prime for this first two term, this will look like this: A1 prime, B1 prime, nakaan sa AO prime, BO prime, ka-OR sa AO, BO. And then dito naman, pwede natin i-factor out si A1, B1. Tama? Common sa third and fourth term si A1, B1. So this will look like this: A1, B1, nakaan sa AO, BO, Okay? Naka-OR sa AO prime, BO prime. Kasi itong natira sa loob, alam natin kung anong logic dito. We know that this is equivalent to an XNOR gate. Tama? Okay. So, we can now convert this further. Okay, so from here, we can, if you can see here, we can AO prime BO prime or AOBO is common to both terms dito. So if we are going to factor out this, ang matitira sa atin dito is ganito. AOBO naka-OR sa AO prime BO prime. Tapos, itong dalawa, A1B1, naka-OR sa A1 prime, B1 prime. Tama? A1B1, naka-OR sa A1 prime, B1 prime. Okay, using the distributive property, to distribute natin to, that would be A1B1 na naka-AND sa AOBOAO or sa AO prime BO prime, this is this term, and then A1B1 prime naka-AND sa AOBO or AO prime BO prime, which is this term. So they are basically the same. Now in this format, we can see that there are two XNOR gates that are gonna be used here. So our final form or simplest form for our A is equal to B output will be AO naka-XOR sa BO and then in-NOT gate natin. Diba? That's our XNOR gate. And then next would be A1 naka-XOR sa B1 and then naka-NOT gate. Now we have our output number 1. Okay, so from this format, so ang daming logic gates, no? We're gonna use na lang, ilan na lang, sa dalawa, tatlo, apat na logic gates na lang. Dalawang XNOR and then, tatlo lang pala, dalawang XNOR and isang AND gate. So that would be our first output. And we can already translate that into a logic circuit. Pero mamaya na lang natin gagawin. Let's finish all the other outputs muna. Okay, so the next would be ito naman, yung ating A is greater than B. So sulat lang natin. This would be our A is greater than B. So yung function natin kanina na A is equal to B is AO XNOR sa BO na naka-AND sa A1 na naka-XNOR sa B1. This is our first equation. For our A is greater than B, yung min terms natin nandito sa 0, 1, 0, 0, and then we have 1, 0, 0, 0, 1, 0, 0, 1, and then this. Ayan. So, meron tayong 6. So, lagyan lang natin to ng zeros. Ayan. So, from this, we can already translate this truth table into our K-map. Hanapin natin yung mga minterms. First is 0, 1, 0, 0. So, nasaan yun? Ito siya. The next is 1, 0, 0, 0. So, ito siya. Next naman is 1, 0, 0, 1. 1, 0, 0, 1. Ito. And then 1, 1, 0, 0. Next is 1, 1, 0, 1. and last is 1110. Okay, so from here we can already make a groupings. So the first grouping would be ito yung pinakamalaki. Ayan, so let's write the the expression agad, the term. So for that, the term would be, as you can see, yung a sub 1 is hindi nag-change and b sub 1. So it would be a1, b1 prime. Okay? And then, ito, another grouping. So let's write it na ulit. As you can see, ang hindi nag-change is a sub 0, b1, tsaka b0. So this would be a sub 0, b1 prime, bo prime. And then the next grouping would be this. So ifo-fold ko yung leftmost and rightmost part of the K-map para ma-group ko siya dito. So mapapansin natin ang mga hindi nag-change is A1, A0, and B0. So this would be A1, A0, and B0 prime. Okay? So now we have our simplified expression using our K-map. But if we want to use our special gates, the XOR and XNOR gates, we can still further simplify this. Diba? So what we're gonna do here is, as you can see, we can factor AOBO prime sa second and third term. Tama? So we can factor out AOBO prime. And it will leave us with AO and B1 prime. Pero hindi pa natin siya ma-convert, di ba? So we can actually, what we can do here is, instead of grouping this, we can do it this way. Okay, so papakita ko lang yung alternative. What if, instead of grouping it, para hindi na tayo mag-multiply ng ayan. Why don't we do it this way, yung grouping? Ayan. Okay? So, itong first group that will be retained, A1, B1 prime, this grouping would be A1 prime, AO, B1 prime, and BO. And this grouping would be A1, AO, B1, BO prime. So, bakit ko ginawa yon? Para pagka finactor out natin ng AO, BO prime, ang matitira sa atin sa loob is A1 prime, B1 prime, and A1, B1. Diba? So, makukonvert natin siya into XNOR. So, sige, gawin natin. A1, B1 prime, and then factor out ko yung AO, BO prime. Ang matitira is A1 prime, B1 prime, naka-OR sa A1, B1. Now, as you can see here, we have an XNOR. So, the simplified expression here would be A1, B1 prime, naka-OR sa AO, BO prime, and naka-AND sa A1 XNOR sa B1. Okay, now we have our second output. Okay, so from using this number of logic gates, ito na lang yung gagamitin natin. So, bakit pinush natin yung XNOR, using XNOR? Kasi, take note that we will be combining these three outputs into one logic circuit. And ano na tayo kanina, nag-XNOR na tayo ng A1, B1. So, ibig sabihin mamaya, kukunin na lang natin yung output nito. Yun yung i-and natin dito. So, nakatipid tayo ngayon ng logic gate. Diba? So, gagamitin na natin ito, yung galing sa una. So, sige, sunod. Sulat lang ulit natin. Our first equation, first expression would be AO na naka-XNOR sa BO. And then, naka-and yun sa A1 na naka-XNOR sa B1. And then our second, f of A is greater than B, it is A1, B1 prime, tama, naka-OR sa, sorry, nakalimutan ko, AO, BO prime, na naka-and sa A1 XNOR sa B1. So we have our first and second. Now what we're gonna get here is, or what are we gonna solve here is, our output for F is A less than B. So kung matatandaan nyo, ang mga less than dito, so ito ay less than si A, less than si A, less than si A. Ito greater than yung A. And then, hindi pala dito greater than. This is less than din si A dito, less than. And then, ang sunod niya is 1011. Ito less than siya dyan. Ayan. So, ilan to? 1, 2, 3, 4, 5, 6. Okay, so let's plot this. 0, 0, 0, 1. Ito siya. 0, 0, 0, 0, 0, 1, 0, 0, 1, 0. So, ito. 0, 0, 1, 1. And then 0, 1, 1, 0. Ito. And then 1, 0, 1, 1. 1, 0, 1, 1. Meron tayong hindi na plot. Ito, 0, 1, 1, 1. Ayan. Okay, so we can group this now. Kung mapapansin nyo, yung grouping nitong dalawa, magkamukha sila o baliktad lang. Nasa taas yung isa, nandito naman siya. Okay, so wag na natin siya. Since we are gonna use an XNOR, let's follow this grouping. Hihiwalay natin yung dalawa. Okay, so ito, isang grouping siya. So f of A less than B. This is the first would be, as you can see here, ang hindi nag-change is A1 and B1. So this will be A1 prime B1. So mapapansin nyo, parang dual sila. And then next is, let's get this muna. Naka-OR sa A1 prime, AO prime, B1 prime, BO. Naka-OR sa ito, A1, AO, B1, BO. Tama. So, I'm sorry, this is 1, 1, 1, 1. So, mali yung ano natin, no? Should be 1, 0, 1, 1. So, mali yung na-plot natin dito. Should be here. So, ito yung grouping natin. Ito po, yung 1, 0, 1, 1. So, nalagay ko siya kanina dito. So, this should be A1, AO prime, B1, B0. Ayan. So, from here, pwede natin i-factor out si AO prime, BO. Sulat muna natin si A1 prime, B1. And then, let's factor out AO prime, BO. So, as you can see here, ayan, no, dual na naman sila. Kanina, AO, BO prime. Ngayon, AO prime, BO. And then, ang matitira sa loob natin would be A1 prime, B1 prime for this term. And for this term is A1, B1. We can see that this is the function for XNOR gate. So our equation or our simplified expression will be A1 prime B1 naka-OR sa AO prime BO na naka-XNOR sa A1 B1. Ayan. So, meron na tayong third expression. Now, kompleto na yung expression natin for the first output, second output, and third output. We can now proceed to converting this or translating this expression into our logic circuit. So, yan na yung sunod na gagawin natin dito. Sulat lang ulit natin para hindi tayo malito. Our first expression, A is equal to B, is AO XOR sa BO, and then A1 naka XNOR sa B1. And then the second, A is greater than B. Function of A is greater than B. It is A1 B1 prime naka-OR sa AO BO prime naka-AND sa A1 na naka-XNOR sa B1. This is the second. And then the third, A is less than B. Parang naka-dual siya, no? So, baliktad lang. A1 prime B1 naka-OR sa AO prime BO and naka-AND sa A1 XNOR sa B1. So, these three, gagawan na natin ng logic circuit. So, let's make ayan. So, I'll label this A1 and then gagawa ko ng this would be A1 prime and then another one and then undate again. So, pasensya na kayo kung bangi-bangi yung ano ko. And then another one. Ayan. So, this would be AO A0 prime B1 B0 prime and then the last. Hindi to B0, B1 prime. And then the last one would be ayan, BO prime. From here, lagay na natin yung tatlong expression. So, for f of A equals to B, so dalawang XNOR, di ba? So, lagay ko muna dalawang XNOR. AO tsaka BO. AO and then BO. And then the next XNOR A1 tsaka B1 naman. A1 and then B1. And then naka-AND yung dalawa. Gawa lang tayo ng AND. Now we have our first output. This is f of A equal to B. So, okay na to. Second is ito naman. So, A1, B1 prime. So, sige, A1, B1 prime. And then, A1 and tama no, A1, B1 prime. Next is AO, BO prime. So, gagawa lang ako ulit dito. AO tsaka BO prime. AO and then BO prime. Yung AO, BO prime naka-AND dito sa A prime, A1 XNOR sa B1. So, ito na yun. So, i-AND ko pa pala ito. Okay. Ayan. And then, yung output nito, tsaka output ng A1, B1 prime, naka-OR. Ayan. Meron na tayong f of A greater than B. Tama? So, ito, nakatipid tayo dito. Instead of using tatlong XNOR, yung output ng first expression, inuulit-ulit lang natin gamitin. So, magagamit ulit natin yan dito sa sunod. So, next, for our third, A1 prime B1. So, gagawa lang ako ulit ng AND gate. First is A1 prime B1. So, A1 prime and then B1. Next is AO prime BO. Ito, AO prime. Then BO. Then si AO prime BO naka-AND sa A1 B1 prime. Gagawa lang tayo ulit dito. Then pupunin ko ulit ito. Ayan. Tapos naka-XOR yung, naka-OR yung itong dalawa. So, meron na akong f of A less than B. So, this is our combinational logic circuit for a 2-bit magnitude comparator. So, medyo malaki yung ating truth table, pero kung bibilangin natin, ilang logic gates ang ginamit. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 logic gates now. Okay? So, we can, pagka ganito na and you want to check if it's, yung pagka-implement mo ay tama, So usually, we can make a prototype kung physically we have laboratory. But for this example, since this will just be ones and zeros, what we can do here is we can try to do it in a circuit simulator. So naghahanap ako ng circuit simulator nakaraan, and ito yung nakita ko. So we have here, you can also try this. It's a website, logic.ly. This actually makaano siya, tawag dito, for logic circuit siya. As you can see here, ang mga laman niya, toggle switch, push button, high na input, low na input, pwede namang clock, square wave yan. Then may output siya, either a light bulb or a 4-bit digital 7 segment. Then ito yung mga logic gates niya, kompleto yan. May dagdag pa nga siya, buffer. So NOT gate, AND, NAND, OR, NOR, XOR, XNOR. There's also a tri-state logic gate. It also contains the flip-flops and labels. So yung ano natin kanina, yung logic circuit natin kanina, ito na yun. So, di ba yung una, for A is equal to B, naka-XNOR yung AO, BO. So, ito yun, AO, BO, and A1, B1. Tapos naka-AND sila. So, this is the first. And then the second, for A is greater than B. So, ito din po yun. Here, you will see here, this lower logic gate. Ayan. This is A1, B1 prime. And this upper logic gate is upper AND gate. This is AO, BO prime. Kasi itong AO, BO prime, naka-AND dito sa ating A1 XNOR sa B1. Tapos, yung output nito, tsaka yung output ng A1, B1 prime, naka-OR. So, this is our F is our function for A is greater than B output. And then the last is ito. For our output for F of A is less than B. So, meron tayong truth table kanina, di ba? Ma-check natin. Ito yon. Pagka naka-white sila, 0 yan, ibig sabihin. So, as you can see here, for 0, 0, 0, 0, ang umiilaw, A equals to B. Equal sila. Tama? We can check the different input combinations. Actually, if you are checking a logic gate, you're simulating a logic circuit, random lang yung ilagay mo sa truth table. And then, pagkatama, yung mga lumalabas, then most probably, there's a very high chance na tama na yung buong logic circuit mo. So, let's try. What if 1, 0, 0, 0? So, i-on ko to. 1, 0, 0, 0. So, A is greater than B. Umilaw yung A is greater than B. What if 1, 0, tas 1, 1? Mas malaki na ngayon si B. Diba? Paano kung 1 lahat? Equal na naman sila. Diba? Paano kung 1, 1, 0, 1? So, A is greater than B. Paano kung 0, 1, 0, 1? So, equal sila. 0, 1, 1, 1. So, A is less than B. So, we are now sure that yung logic circuit na nagawa natin is correct. It's a 2-bit magnitude comparator. Okay, so that's how we design combinational logic circuits. So first is you have to identify the problem. Next is you have to identify how many variables are we going to use. Out of that variables, we can identify how many input combinations are there. And of course, we also have to identify how many outputs are we talking about. So in this case, in magnitude comparator, we have 3 outputs. And then after that, we have to assign the variables, the letter symbols. Then we're gonna fill out or complete the truth table. From the truth table, we're gonna make a K-map. From K-map, we're gonna obtain the simplified expression. From the simplified expression, we're gonna translate it into our logic diagram. From our logic diagram, you can, if you have an access to the internet, or you have an offline circuit simulator, or you have a circuit board, okay, or a trainer board where you can do a prototype, then you can make the circuit para ma-check natin kung tama ba siya or hindi. Then pagka tama siya, then you can already make the circuit. Okay, so thank you for listening and watching this video. I hope you have understood something sa magnitude comparator. Okay, so thank you and good day.